Okay.
Okay, so were you able to try that null pointer for your concurrent hash map and hash table?
Oh, yes, Neha, I have tried, but when I try to execute, right, I got some null pointer exception actually. So I'm not sure whether I did correctly or
So the hash table was not allowing you to add null, right?
both. I tried for concurrent, I commented this and tried for hash table. For both, I'm getting the null pointer exception.
Hmm. Okay, can you just comment the line? Can you scroll? Yeah, comment the line number 16. Okay, now can you just execute? And even in that one, you comment 30th line. Yeah, execute. Can you go to that line number 17? Okay, so the map dot put null of 6. So the key is your null and the value is 6, right? Earlier in hash map, we were able to add our null keys, right? Whereas in concurrent hash map, we are not able to do that. Why is it so? Because internally the hash map will not allow any null value or null key. So that is the learning point here. So if you want to have null, so what happens internally in your bucket list when you're mapping your null key is all the null data, right, will be mapped to the index position of 0 in the entire array list of 0 to 15 indexes. So that was working fine in case of hash map. Whereas in concurrent hash map, that is which is internally using the hash table structure, it's not feasible to have null key because the hash table and concurrent hash map both can be used in the parallel environment, like multi-threaded environment. So whenever you're using in a multi-threaded environment, when one particular value which is holding the null key will create problems on synchronization part. So because these concurrent hash map and hash table both are used only for thread safe environments, right? So basically multi-threaded environment, we prefer to go with these two classes. So that is the reason the hash table internally will not accept null as a key. So if you go to the concurrent hash map or hash table class, can you just give control so you can go to hash table or concurrent hash map? Go to the put method, control O and give put method. Now go to the put value. Right? So what is the first condition you have? If key is null or the value is null, throw a null pointer exception. Now, same thing, can you open in your hash map dot class? Hash map. You already have the import package. Yeah, go to that. And go to the put method. No. Control Z. Control and click. Go to put method. Go to the put value. So are we validating here the null check? Like whether your key is null or not as we did in concurrent hash map?
No, we are not doing
So that is the reason in your hash map, though your data is not present, like null key is present, it will not explicitly validate it. It will instead consider it as the 0 index and it will add the data in that index. Whereas in case of concurrent hash map, we validate explicitly whether your key and the values are null or not. So the main difference is you can have null as a key in case of hash map, which is fail fast iterator. Whereas in concurrent hash map, you can't have null key or null value. So that is the understanding of this use case. Got it, Janaki and Yoga? Or any questions?
Yes, Megha, got it.
Okay, fine. So now create a class called comparator versus comparable. So what
Is
this comparator and
the
create a new
similar case
class.
only for the hash table also, right? Like
Yeah,
it
yeah,
will
you can
have
go
the
into hash table and check your put method.
check it.
You'll get it.
Okay.
Now create a new class, comparator versus comparable. So once you have created, okay. Now, so what is this comparator and comparable interfaces does? So we need to understand the context behind these two interfaces. Now, can you create one Pojo class, either employee or something, create something new Pojo class, new and class, and give teacher. Just give teacher as your class name. Okay. And the teacher has ID and name. So just go into it, finish. Now, near class teacher, yeah, add the two attributes, private int ID and private string name. Okay, create your, no, string is class, right? Why are you making it?
Class which
Create your constructor, default constructor, and then the getters and setters for ID and name.
you want to create getter and setter, right?
Yeah, just give
Or
ID.
I can load it.
Source, no, above, after quick fix.
Yeah.
Generate getters and setters. Down. Okay, save this. Now, what you have to do is, in the same file, can you go to the top teacher and the class name teacher? Yeah. After teacher, give implements. So this is an interface. For interface, we use the keyword implements, right? So give implements and type comparable to control space. Okay. So can you go to that comparable, control click and go to that class comparable? Okay. So what is this one? The comparable interface does, and what is that T angle attribute, which is within the angle brackets. So this comparator is something which we use to do a sorting operation. So this comparable is coming from which package? Can you tell me from which package we are getting this comparable?
Java.lang.util.
Yeah, so this is coming from our base package, which is java.lang. Okay, so when was this introduced? This was introduced in 1.26 version, okay, of Java. Why do we need this comparable interface? What is the main purpose of this comparable interface? Is this comparable helps us to do a sorting in a single sequence. And if you just give Control O in this, you can see a method called compare to. Can you go to that? Yeah. So that accepts some object and returns an int value. So what is that int value? So basically, it's going to compare two objects. Okay. So you're going to compare it, and then that gives an integer value, whether it is less than 0 or greater than 0 or equal to 0. Basically, to identify the sorting purpose, like whether I can go to the left side of sorting or to the right side of sorting, or I can just keep it in. So you have an idea about usual sorting, how do we do the bubble sort or a quick sort? Any ideas on that in algorithms? Have you ever came across those terms and usage?
I have heard that in data structure, but I I don't know that exactly.
Okay.
Those
So the basic thing is, let me share my screen. Okay. So what happens usually is, let's say now, I have 34, 45, 67, 78, 23, 13. So usually, if I need to sort this data set, right, what is the actual output we know, the sorting order? Can someone say the sorted values? 2, 13, 23,
23,
34,
34,
45,
45,
67,
67,
and
and
70. This is the ascending
78.
sorted order result set, right? But how can we achieve this? So there are multiple algorithms to do that. So if you see there's a bubble sort, there's a merge sort, there's a quick sort. So there are multiple sorting algorithms available. So as we have the linked list and the array list, like how we can store our data and where the retrieval would be really fast, the same way the sorting helps us to do the ascending order or the descending order sorting in a more efficient way. And so to do this sorting, there are multiple ways. So what they usually do is they divide it based on the number of elements. So right now we have 1, 2, 3, 4, 5, 6, 7 elements. So the 7 elements divided by 2 is 3.5, right? So they go with the maximum value. So they segregate these values into two sections. So 34, 45, 67, 78 would be one set. And the other set would be 23, 13, and 2. So now we compare each element with the other. So right now 34 and 45 will be compared. We'll see whether they are in the sorted order. The answer is true. So what happens? This would be again split into part, like a 4 by 2, just 2. So 34 and 45 as one section. And the other section would be 67 and 78. Now, both are in the sorted result set. So we are good in this. Now come to this part. So this is again like odd number. So what happens? 23, 13 and 2. So the two sections would be separated here. So this would be one and this would be the other section. So now this would be, it's not in the sorted result set. What we do here, we compare the elements. We say 23 is greater than 30 or not. The condition is true, but we need this sorted one, the ascending one before. So what happens, the compare to method, which we might use right now in some time, helps us to compare the result set of these two and gives an integer. 23 is greater than 30 in condition true. So in that case, what I have to do, I have to reverse the order of these two elements. Now I have this 2. Now the entire data is being sorted. Now we have to merge together to get the final result set of this one. So what we do again, we merge these two again and we see 34, 45, 67 and 78 on the ascending order. So this is done. Now coming to here data set 13, 23 and 2. Right now the data is not in the proper ascending order. So what we do again is we compare each data set again. Then we sort our data set and we merge our data set. So right now what happens? Your 2, 13 and 23 would be coming out. So this is like divide and conquer. They usually say divide and conquer. So we divide the data set and we divide. And finally, once we achieve the result set, we merge them. So this is like, sometimes they call it as merge sort, sometimes they say it as quick sort. But the end of the result set is you got this one, 34, 45, 67, 78 and 2, 12, 23. Now we again need to merge these two and the data set is not in the ascending order. So what we do again, we compare each element in the entire data set and we order the final value structure which we require. So this is the divide and conquer mechanism which we use to achieve our sorting way. So You got any clue at least like how the sorting happens here? Hello?
Yes,
Yes, ma'am.
like it will divide, and again when we try to merge, it will again validate each element and put it in ascending order, right? That's what this divide and conquer.
Yeah. So this is basically like you're dividing your data set, you're basically partitioning your data, and then you're exchanging the data set based on comparison, whether this value is greater or lesser, we're comparing it. And finally, we are achieving the actual ascending order result set. So this happens till we finally achieve the actual output. So this is a repetitive process. Okay. So this is called as divide and conquer. So whatever the element size is, okay, we are actually divided by n by 2. So this is called also merge sort, because what happens once you partially separate your data set, right? You need to merge them again. Only then you'll get the final data set, the same 7 elements. Otherwise, you'll have it as 2, 2, 2, and 1. So this is not the actual output. So what we do is every time we partition our array values, and on every partition of values, we store the sorted data set in the first half. And then we come back to the rest half of the data set, do the sorting again. And then once we feel like, okay, I have come up with the final result set like 2, 12, 23 in the second half, I merge them back to the initial sorted value of first half of the array. So this would be the process, okay? And that like you can just go through to Google, like what is quick sort, what is merge sort. So this is the main understanding. You divide, you compare your data, and post that you reassure that your data set is ordered. And then we finally merge the entire data set and give the entire final structure of the value as expected. But this is a tedious process because right now we have 7 elements. For that, how many iterations we went? We went first level, then the first level is, it's kind of a tree, right? So you're separating it this one and then 2. And this one is again getting segregated with child left and right. This is again getting segregated with left and right. And then this will be again segregated to left and right. And post comparison, we reset the order. So the number of height of this element order, if you see, this is your root, which has 7 elements. And now this has 4 elements and this has 3 elements. Now this 4 is again divided into 2 and 2. And this 3 is again divided into 2 and 1. And again, this 2 is again divided into left and right child. Okay. And this will be again divided into left and right child. And this again divides into left and right child. And this has only left child. So what happened? The level of the 7 elements is 1, 2, 3, and 4. So totally 4 levels of iteration is happening to get you the final sorted data set, right? So which is very tedious. So in our Java programming, to make it more easy for us, they have given us something called comparable interface. If you're trying to do some sorting, and if you want to sort based on teacher's ID or teacher's name, or if you wanted to create your own sorting sequence, like the ID, say for example, like if you go to any organization, the employee ID would be varying for each organization. So some will have like the first 3 letters of the organization name, followed by the date of birth of the employee, followed by the actual 5 digits number of the employee. So there might be different structure to create your IDs. So when you want to sort them and get the final object of your teacher or your employee or your student in the sorted order, then we have something called comparable interface given from your lang package that has this method called compare to, which returns an integer value. So if that integer value is greater than 0, I can do one operation. If the integer value is equal to 0, I can do one operation. If it is less than 0, I can do one operation. And based on this, I can perform my sorting. So are we good with this concept? So if you're clear, we can try the implementation part.
Yes, ma'am.
Yeah, Janaki, you can share your screen and stop. So what we have to do, we are going to implement this comparable interface to our Kojo class teacher. Okay. So now go to your teacher class. And now if you see there is an error in the line number 3. Why is it so? Because you have to import that compare to method, right? Whenever you have this method, you have to write your own logic and then compare to. Right now you have the method in comparable interface. So what is interface? It tells you what to do and not how to do. So that how to do is something you're going to write right now in your teacher class. Now, if you see the comparable interface has something called T attribute. What is that? So that is nothing but the actual Pojo class which you're looking for. So the Pojo class for which we are trying to implement comparable is teacher. So now you have to write teacher over there. That is your object. Now that is done. Now what is the issue? You haven't implemented the method of compare to. So how do you implement? Give control space, right? No, not that one. You have the method compare to in your interface. How do you override that method in your teacher class? After line number 21, give control space. Import that. You override that compare to method. You need to be in touch with the implementation as you pass the classes, and if you don't remember, then it would be tedious for me to recollect every time. If it's an interface, you have to override the method, right? You have to write your own logic.
I thought like I need to first import that comparable class.
You
for
already
that
imported it, right? In the class, root class, you already gave it as implements comparable, right?
Oh, okay.
That is from a lang
Like,
package. So you don't need to have a package name.
oh.
Okay. So now you have a method compared to, and right now that is nothing but it is returning 0 default value. So we are going to do a comparison based on name. Okay. So what we'll do, our logic is within the compare to method, write one if condition. If by object.
Object would be the teacher.
No, the object is the reference O, right? O dot.
Yeah.
So you have the name, right? So we are going to compare it based on the name. So go click the name attribute, the second parameter. Yeah. So you're going to compare it with the name attribute of the same class. So your left side have the name again. Name equal to 0 O dot name. No. Name has to be the first attribute. Before equals to have it as name, and after equals to have it as O dot name.
Okay.
So if the data is equal, I'm going to return it with 0. Okay. Now have one more if condition, else if. Else if. Now here we are going to compare whether it's greater than or not. No, same attribute. You're going to use the same name. So name greater than O dot name. Then return 1. If it is lesser than, which is your else case, okay, else return -1. Okay, so we are comparing 3 scenarios. Equal to, what is the error you get in that? 33.
I think.
Okay, so we can use ID instead. Like right now you can have ID because that is an integer, right? Yeah.
Oh, yes.
Rename the entire name with IDs.
Yeah.
So now you have added a compare to method. So based on this, your data of your teacher object should be sorted out. Now go to your comparator versus comparable class. In your main method, create an list object with teacher and add some random elements of teachers with different IDs.
For list, right?
Yeah. For list, add your teacher object. No, not integer. I'm asking you to create a list with teacher. Teacher is your Pojo now, not integer. Yeah. No, you shouldn't add it as an integer, right? You have to create a teacher object. New teacher of.
Oh, okay.
You have a parameterized constructor and create an object there. No.
Okay.
You don't need to create explicitly. You know how to create object, right? Use the same thing. New teacher of, have a parameterized constructor so you can pass both ID and name together.
Just a variable with new class, right? Like equal to new.
No, first go to teacher.java. Create a parameterized constructor with ID and name. Right click and you have the same way to generate, right? You can use it.
That one. Okay.
Control Z. Right click. Source. Generate constructor using fields. And select both. Yeah, generate. Okay. Now go to save this file and go to the comparator versus comparable. Now here in the list object, instead of 12, give new teacher of and give the ID and name. Give 2 as in the last list.
Yeah.
Okay. Now you have to import the array list. That is the reason you get the error there.
Oh, yeah.
What is the issue there?
This one, which I usually. Yeah.
Now use for each loop and then print the list of the teacher's ID and teacher's name. Use for each, not normal for loop.
Okay. I'm yet to watch the array list actually, the missed class actually.
Okay, this is a normal iterator, right? For each iterator. How do you do it? You have to create a colon and your right side, you have to iterate your list and the list is of teacher object. So you have to create an instance of teacher on your left. And yoga, you remember the for each iterator?
So it should be int, right? Actually, the variable which we want to do.
No. Why is it should be int? What is the list is giving you? What is the written type of list here?
List, it contains both int and int only it will return, right? Because teacher object will return.
No. What is teacher? Teacher is an object, right? The teacher object has 2 parameters of integer and string. But what is list returning you? It is given in only teacher object, right? So you have to take the return type as teacher. List, you have it as li and you have used list as the reference. Open and close. Okay. So whenever you're using for each iterator, the return type of what, see the for each iterator comes when you're doing a list or an array iteration, right? So right now you're doing an iteration on list. What is the return type of list here?
This one.
Yeah. So then that is the object you're going to iterate. So instead of 10 elements, you're going to take 1 element on each row. So in the normal for loop, what you'll do, you'll give int I equal to 0, I less than list dot size, I plus plus. And within that, you'll get, the list object dot get of and the relevant index position. The same thing we're doing it, but instead we're not using the index reference. We're directly giving it as the teacher reference. Now, within the for loop, sys out, like your println statement. T1 dot, use the object T1 dot, and you can see you get ID and get name. So use get ID and print it. And in the next line, print the name. So right now, we are just iterating the list and we are printing it. We didn't do anything else. So now execute this program. Yeah, that is known, right? We have only these two, so no issues.
Okay.
Yeah, okay. Execute it. Now execute the program. So your data, if you see right now, the data is not sorted. Whatever data you have inserted, 12, 76, 2, you can see the same output, right? ID 76, 12, and 2, in the same order. It is not sorted. If it has sorted, what would be your output? 2, 12, and 76, right? You didn't get that output. Though you have implemented compare to method, you didn't use it. Why so? The thing is, though you write your compare to method, you have to say that I'm going to use my sort object. Or I'm going to use a sorting reference here. Only then your sorting works. So otherwise, it will not consider it as a sort. So what we are going to do right now is, before for loop, write collections. Collections is a class. So write collections. Yeah, give control space. Don't write. Anytime when you're writing a reference, then don't write it completely. Use a reference. So there's always the last class. Okay, give control space. ECTI, collections, right? Yeah, now if you see, there's something called collections class from last third one. Click that. Okay, now go to the class collections. Okay, then you give control over here. So if you see down, there is something called sort with list of object, sort with comparator. Okay, so there are two methods. Can you go to the first method, sort? So what is the structure you have here? The sort method accepts what? List object. And in your return type, after static method, you have something called T extends comparable. And within angle bracket, again, you have any class, which is question mark. It can be any class, super of that parent class. So now if you open your teacher.java, can you open teacher.java? So on top, can you scroll up? So you can see here comparable, and the parent class is as teacher in the line number 3, right? So you're using a comparable for your teacher object. Now go to your collections.class. So here the sort is nothing but it accepts only in list object. But internally it is using something called T extends comparable. So you're already extending the teacher, right? So what we are going to do right now is go to, this is just a static method, but it is going to return void. The return type is void. Okay. So it doesn't give you anything. It's just going to perform the operation. That's it. Now go to your comparator versus comparable class. Now use the method sort, which is a static method. The first sort method, and pass the list object li over it. Save it, and now execute your program. If this meeting ends, please rejoin the same meeting link. So if you see the output now, you can see 2, 12, and 76. The data is sorted. How will that happen? Because the sort method uses something called comparable interface. And that comparable interface is of where you have implemented on your teacher object. The list also returns you the same return type teacher. So now the compare to method is working. So have a debugger on line number 39. Yeah, now try to debug your same program. Give F6. So now if you see here, what is ID you received? Value of ID. What is ID? 76. What is O of ID? On your right side, there's a variables, right? You can check from there. What is the ID you got?
76 and O
The
of
current
ID
object
is
is having 76 and the object which you passed or compared to was having 12. So is 76 greater than 12? Condition true, right? So you'll return 1. Next, give F6. Go ahead, F6. Go ahead. So what is happening here? You're comparing it, whether it's an ascending order or a descending order. The comparable time sort function is helping you to calculate your data set. So if you see as a programmer, you have used only the compare to method. And if it is less than, you're giving 0. If it is greater than, you're giving 1. The same thing here, they have written its own logic. So every time I get an input, I'm comparing the data. I'm using a compare to method and I'm subtracting the data set. And finally in 329, I'll get an output. So have a debugger on 329 and give F7 or F8. F8. Okay, now what is the ID you have and what is the O dot ID?
ID is 2 and O dot I is 76.
Okay, so what will happen now? In which scenario will go now? The 2 is equal to 76 fails. 2 is greater than 76 fails. So it should go to the else block. So just give F6 and go. So it will end up in else block. So you got a value of -1. Yeah, go ahead and give F6 again. Okay, so if you see right now, it is coming in the else block. So it is preferring to go with ascending order because the 2 comes in the first set. So you got your data. So since it's executing the else block, your order is happening in the ascending order. Now go ahead, give F8. What is the value you have? Just inspect that element, run hi minus LO.
I need to come out of that line, right, to check next line.
Execute it. Just give F6. Yeah. Now, what is the value you got here in init run length? In line number 188, you have something, right? What is that init run length? Double click and then inspect that element. Okay.
Again,
Just give F6. Give F6. Now check the value of run length. Okay. Go ahead. Maybe this might be in a strange spot. Yeah, just go ahead. Now, what is the object you have again for O?
Again, we are getting
The same value, right? Now give F8.
F8 or F6?
F8, or you can go F6, anything you wish. So that's it. Your data set is done.